Hello everyone, welcome to this presentation by iBeam Materials. Vladimir, Matias, founder and president of iBeam Materials, will be presenting. And I think it's really an interesting technology because one of the key problems with LEDs has been that you have to grow them on, let's say, sapphire substrate. But Vladimir and his team are trying to change that and make it possible to grow LEDs and similar substrates on substrates like glass or foil and also to so go through. So I'm going to leave the stage to you, Vladimir. You have up to 20 minutes. I will give you the heads up, 2 minutes, 3 minutes before the end of your talk, and then the room remains open for Q&A.
Hello, my name is Vladimir Matias, and I'm from iBeam Materials in Santa Fe, New Mexico. I want to thank the organizers for the opportunity to present today. I'm excited to present our materials breakthrough for making large area sheets of gallium nitride-based LEDs. Not only is this technology transformational in how LEDs are manufactured, going from small wafers to very large scale, but also in enabling super bright, paper-thin, flexible displays. Here's a brief outline of my talk. I want to first introduce iBeam Materials, our company, then describe some of the challenges of using LEDs in displays, and then I will describe briefly only the technology for making what we call GaN-OX, GaN-on-X, a new platform for making LEDs, and then implications for LED manufacturing as well as in use for displays and in lighting. Our company, iBeam Materials, was started about 10 years ago as a spin-out from Los Alamos National Laboratory and is located in Santa Fe, New Mexico. We're the leaders in ion beam crystal alignment technology, where one deposits a film with an ion beam during deposition, which allows us to align the crystallites in the film during growth. This is a way to make large area epitaxy. And epitaxy is where one deposits a material in atomic registry with the substrates. Traditionally, epitaxy is done on single crystal wafers. This technology was actually first introduced and developed for superconductor wire manufacturing, where one deposits epitaxial superconducting materials in long length via roll-to-roll processes. Today, there are about a dozen companies around the world making thousands of kilometers of these tapes. It's one of the largest applications of epitaxy in the world today. iBeam is currently using this process to develop templates for epitaxial growth of gallium nitride using our roll-to-roll reactors. Our leadership consists of myself and then Julian Osinski, who is a veteran of the opto-semiconductor industry, and Klaus Kunze, who is a veteran of chemical coatings industry. Light-emitting diodes, or LEDs, today come essentially in two forms. Inorganic LEDs, that I will call iLEDs, are extremely bright and efficient sources of light. They are very robust and stable materials. Today, they come typically as points of light because they are coming from tiny chips. This is because they're expensive to fabricate because of the epitaxy that is required. Because they're such tiny points of bright light, they produce a lot of glare, and it requires optics to diffuse the light. Consequently, there's a lot of costly back-end processing for iLEDs and individual die packaging and handling. On the other hand, we have organic LEDs, or OLEDs, which are made in sheets. They're very inexpensive per unit area, and they're not nearly as bright. In fact, they're 100,000 times less bright than the iLEDs. And they're also environmentally sensitive to oxygen and moisture. Today, iLEDs are primarily used in lighting as well as in